Welcome to the lecture on economic order quantity. So, in line with what we have studied the break even analysis, similar to that many a times in the inventory control department in the plant, we need to find the order quantity or purchase quantity that should be the most economical one. So, basically a decision has to be made and it is to be ascertained that what should be the quantity of the order, so that your total cost for maintaining the inventory for the period should be minimum. And for that there are many things which are to be studied, like we know that what is the requirement for the year. And one thing is that you can have the whole requirement with you at the beginning of the year, so that you can use it for the whole year. So, one extreme is that, and for that there are many challenges, so that we will discuss. First of all, let us define what is why we try to study this economic order quantity. So, the company has to purchase the inventories required throughout the year. So, basically whenever we are dealing with any company, we are in the need of these inventories for whole year, and the company has to purchase it. Now, purchasing can be done in a year or on daily basis. Both these cases are the extreme positions, extreme situations. Means the best thing and most easy, which looks like, will be that you take you purchase all the items once, and whole year that will serve your purpose. The second extreme is that you every day you purchase, every day you purchase and use it wherever required. Now, both these things are extreme in the sense that if you are taking the whole purchase, whatever requirement you have there in whole year, then it is very difficult to maintain. You have a lot of holding charges, you have to keep in a very big space, you will have to maintain it. So, basically the holding charges will be very high, and in that process there are many items which it will be many a time difficult to relocate, or some may be spoiled or so. So, that is one extreme. Another extreme is that you take on daily basis. Now, in the daily basis, basically every day you have to process for the purchase. So, you have a lot of charges into that. You have to make the purchases. So, for that you will have the cost on purchase every day. So, that will be basically very high in that case. So, they are the extreme situations. So, what practically it is followed in the industry is that we should have the quantity which should be purchased in one order, which should result into minimum cost. So, this quantity which is ordered every time, that results into minimum total cost, that is known as the economic order quantity. So, how to get that? So, that is again a type of something like break even, because that will lead into minimum cost. So, it is on the similar line, and let us see that how can we we can proceed for getting this economic order quantity in the plants. So, let us say that you have the TC defined as the total yearly cost. So, that will be total yearly cost of providing the item, that will be TC. Then you have D that is the annual demand basically. So, demand in any definite time. So, you can write that annual demand of the item is D. Then you go for n number of purchases. So, n you can take as number of purchases in a year. So, basically n will be there required, because on n number of occasions you have to make the purchase orders, you have to process. So, that involves cost. So, cost of purchases will be there for n number of times, that is n. Then T is the time between purchases. So, T we define as the time between purchases, and then we take this Q as the purchase quantity. So, that will be basically we will be getting the expression for Q, which will minimize this total cost, and in that case we are going to have the expression for Q. Then CI, that is the item cost per unit. So, that is your purchase price, and then CP is the purchase cost per purchase order. So, these are the input parameters in the term of what we are going to have the expressions, and another term will be the CH, that is your holding cost. So, this is the holding cost per unit per year. So, basically it is made up of many items like interest, insurance, taxes, storage, all these cost components are, or spaces or handling, all these components are into this holding cost. So, then what we need to know that we have to have the expression for the total yearly cost, and if we find the total yearly cost total yearly cost, which is defined as TC. Now, this TC will have 3 components. One is that will be the item cost. So, this will be item cost. Then you have the purchase cost, and then you have holding cost. So, item cost will be the cost of the item. So, you have annual demand is D and item cost per unit is CI. So, first of all we write item cost as IC, purchase cost as PC, and holding cost as HC. Now, item cost will be basically you have the total demand is D, and that will be multiplied by cost of the item per unit. So, item cost per unit is CI. So, CI into D will be your item cost. Now, purchase cost means you will be dealing with the purchases many number of times, and we know that we are doing the n number of purchases. So, for every purchase order we are having involving a cost of CP, and we are doing n number of purchases. So, purchase cost will be number of purchases in a year, that is n, multiplied by the purchase cost per purchase order, that is your CP. So, that will be your purchase cost. Now, we are talking about the holding cost, and holding cost will be nothing but you have the inventory which is stored, and for that basically this is your inventory holding charge per unit per year. Now, what is there that what you see you have the inventory flow like this. So, what you do is you are ordering for Q quantity, and the ordering time in between orders is T. So, after T time you are ordering again, and you are here you have certain assumptions, and the assumption is that there is no time lag between so here there is no time lag. So, once you order you are thinking that you are getting the material in time. So, there is no time lag in between, and here again this Q quantity comes in. So, what you see that this Q comes and it replenishes in T time. So, your average inventory level is Q by 2, and so the holding cost will be average inventory level, that is Q by 2, and that will be multiplied by the holding cost per unit. So, it will be CH. So, this is your expression for the holding cost. Now, coming to the expression for PC, if you look at the PC is the purchase cost, and this is N. So, N, you know that this is number of purchases in the year, and number of purchase in the year will be demand divided by the quantity. That is what will be the number of purchases. So, you have total demand of D, and you are ordering for only Q at one point of time. So, altogether you have the N as D by Q, and then that is multiplied by Cp. So, on the whole you have three expressions: IC equal to Ci into D, then PC as D by Q into Cp, and holding cost will be Q by 2 into Ch. So, the expression for total cost, total annual cost, will be Ci into D, first part, then you have Cp into D by Q, and then so that is your purchase cost, and then the holding cost, that is Ch into Q by 2. So, this is how your three components look like. Now, what we have to see, we have to find what should be the quantity, what should be the quantity ordered, so that your total cost becomes minimum. So, we know that this is a function which is shown in terms of Q, and this function which must be having the minimum value. For that we have to take its derivative, and this derivative value should be equal to 0. So, once we equate that to 0, in that case we will get a condition which will give you the minimum total cost. So, we can write that for minimum total cost value, your d by dq of total cost should be equal to 0. So, for at minimum value the slope will be 0. So, we know that Tc is Ci into D plus Cp into D by Q plus Ch into Q by 2. So, if you take d of Tc by dq, that will be equal to this will be 0, then this will be minus of Cp into d by q square, and then this will be Ch by 2. So, that has to be equated to 0. So, this leads to Cp into d by q square will be equal to Ch by 2. So, q will be equal to 2 into Cp into d by Ch and whole under root. So, this is the economic, or this quantity which you get, this quantity is known as the economic order quantity. So, you can have examples, and that examples will these data will be given, and once you have these data, then you can get the value of economic order quantity, and at this value of q you will have the. So, if you find the expression for or the graph of the total curve, total cost line, in that case at this value of q, if you take the different values of q, then if you find the graph, so for that value of q you will have the minimum value of the total cost. So, let us say if you have some examples like you have annual demand for certain item is it is given as 1000 units, and suppose cost per unit is given as rupees 6, and then purchase cost per purchase order is also supplied. So, purchase cost per purchase order is given as rupees 10, and then cost of holding the inventory CH, the cost of holding the inventory in 1 year, it is estimated to be rupees 132, 1.32 per unit. So, for per year. So, if suppose these values are given, we know that these this is very clear from this expression that we can get these values. So, for this problem, if you try to find the economic order quantity, then simply you put in this expression, that is q will be the under root, and you have 2, and then Cp is written as 10, and then you have demand is 1000 and divided by Ch. So, Ch will be 1.32. So, if you do that, it will be coming something like 123 units. So, this will be, so it means that if you order once 123 units, so you will be going something like 8 times you will be doing the ordering. So, 123 into 8 is 984. So, it will be coming something close to 8.12 or so. So, so in that case your total cost is minimum, and this you can verify by plotting a graph. So, if you plot the graph of total cost with respect to the purchase quantity q. So, what you will see that for this 123, it will be minimum. It will come something like this kind of curve will come. So, for this suppose it is 100, so it is about 123, you will be having the minimum point. So, this is a TC line. So, at this line you will be having the minimum value of total cost. So, that talks about the economic order quantity, which results into the minimum of the total cost when mostly that is used in the case of inventory management, where you require to order and how much to order once, how many times you must order and what quantity, so that your total cost is minimized. Now, similarly the line you will also come across certain terminologies in the plants, and that is your economic production quantity. So, many a times in the plants you have to determine the optimum production quantity, so that that results into the total yearly cost to be minimum. So, so in those cases what should be that production lot, in that this production should be made, and that is known as the economic production quantity. So, that is your EPC, economic EPQ, that is economic production quantity. So, in those cases you will have the data, again you will have the data like TC. So, you have the data TC as the total yearly cost of producing item. Then you have D as the yearly demand of the item. Then you have N as the number of productions runs. So, that is number of production runs per year. Similarly, you define T as the time between production runs, and you have Q as the production quantity. That is what is optimized value we have to find. So, that is your production quantity. Here again you have the definition of CI as the item cost per unit or production cost. So, that is your production cost. In that earlier case you had that one as purchase cost. Then CS in this case will be setup cost, because every time you have to set up. So, that will be setup cost per production run. So, in this case you have to have the setup, and in that you need to have the to put into the cost. Then you have again here as a CS, that is your holding cost per unit per year. So, per unit per year. So, again it is meant for the similar type of costs like storage, insurance and all that. Then you have R as the production rate. So, this is your production rate of of producing the item. Now, again in these cases we are assuming that the demand basically is constant, and also the production rate is constant during that period. So, you have to have certain assumptions. This assumption is also valid for the earlier cases, and again we also assume that the lead time is 0 here, production lead time is 0 and there is no shortage. So, these are the assumptions which were also there during the expressions which were found for the economic order quantity. Now, in this case again we will be having the expression for the total cost, and the expression for the total cost in this case will have again you have the item cost for the year, and similarly you will have the setup cost for the setup cost. So, you will be having setup many times. So, that is your setup cost for a year, and similarly you have holding cost for the year. So, this way you will be having 3 cost components, and we define it as IC plus SC plus HC. So, this is what we did in earlier cases. Now, in this case again IC will be that is CI into your demand. So, CI into D. Now, setup cost, you are doing the setup n number of times, you are going for the production runs n number of times. So, it will be again in the similar line, setup cost will be setup cost for every time is CS. So, CS multiplied by n, and again n will be your demand by production quantity. So, it will be CS into D by Q. Now, comes the holding cost for the inventory, and in this case what is happening that the production rate is R. So, we know that if the items are added to the inventory at the rate of R units per year, and taken from inventory at the rate of D per year. So, in that case the net rate of accumulation is R minus D per year. So, that will be your net rate of accumulation R minus D, and the time required to produce these D units at the rate of R. So, that will be your D by R. So, in that case what we see that what happens that the maximum accumulation of the inventory will be basically R minus D divided by D by R. So, that way your maximum accumulation of inventory so you will have R minus D. So, R is production rate and D is your demand. So, that will be accumulation, and then your since that rate is D by R. So, it will be divided by D by R. So, this is your maximum accumulation, and then minimum accumulation will be so 0. So, since because there is no storage in fact, So, your average accumulation, so average number of inventory, so average inventory since minimum is 0. So, average inventory will be r minus d into d by r plus 0 and then by 2. So, it will be r minus d into d by 2 r. So, this is your average inventory in the case of these production runs. Now, since you are making n lots, so since n lots are made, so your average number of units in storage so it will be divided by n. So, it will be r minus d into d by 2 n r. So, this will be your average number of units in storage, and this multiplied by the holding cost, because holding cost is for every unit, we are paying the holding cost as Ch for every unit and every year. So, this is to be multiplied with Ch, and that will give us this holding cost for the year. So, in that case, so this is your average number of units in that storage. Now, in this expression also again, since if you take this n will be nothing but d by q. So, as n is d by q, so your average number of this becomes r minus d into d by 2 into n is d by q. So, q will go there. So, q by 2 r. So, this will be your average number of units in the storage, and then H c holding cost will be this multiplied by C h. So, it will be C h multiplied by r minus d into q upon 2 r. So, this is your holding cost, and then what you do is that you get the expression for the total cost, and then you are differentiating that with respect to q. So, T c will be C I into d plus C s into d by q plus C h into r minus d into q by 2 r. So, that will be there, and then you further find the dTc by dq as and equate it to 0. So, if you equate it to 0, so it will be, this will be anyway 0, and then it will be minus of Cs into d by q square, and in this case you will have Ch into r minus d into 1 by 2 r. So, we have to equate the two, that is to be equated to 0. So, you will be getting the expression for q, and q will be 2 r into Cs into d. So, that way it will be coming. So, you will find the expression for q as and under root 2 into Cs into d upon Ch into 1 minus d by r. So, that is what finally you get the expression for the economic production quantity. This much of production should be made in one lot, so that your total cost is minimum. So, this is how you use, and similar to that previous economic order quantity question, you may have these datas for the problems, and you have to put these values into this expression, and it will give you the economic production quantity values. So, that can be evaluated, and that leads to the value of that quantity, which gives you minimum total cost. So, this concept is very much utilized for for getting these values of quantity, which give results into the optimized cost, optimized total cost, minimum total cost, and it is based on that analysis which we have studied in our earlier lectures. Thank you very much.